Hello student, here we discuss about enthalpy of neutralization. This is for 11th purpose IIT and other competitive exam. It is pH dependent and temperature dependent. Delta is neutralization for strong acid and strong base, and for weak acid or weak base. Thermodynamics, physical chemistry we are discussing. One of the student has asked about उदासीनीकरण की एंथैल्पी. यही उदासीनीकरण की एंथैल्पी है. Okay, I will tell you in Hindi also. Don't worry. So enthalpy of neutralization is pH dependent. Why I am saying so? When a strong acid HA react with a strong base, completely dissociate. Always it strong acid and strong base completely dissociate, and it will form 1 mole of water. Remember, 1 mole of water. 1 equivalent of H positive react with 1 equivalent of OH negative and will give 1 mole of water molecule during the time of complete neutralization of strong acid and strong base. I took example of HCl and NaOH. NaCl and water is obtained. Remember, I am saying water. Okay, so H from acid and OH from this alkali is obtained and we'll get water, and amount of heat energy release in kilocalorie, it will be minus 13.7 kilocalorie. Here I took minus 13.7, that is delta H neutralization. Okay, in terms of thermodynamic term, and delta H neutralization for acid, strong acid and strong base, it is here for this reaction minus 57.1 kilojoule per mole, and it ranges with temperature 57 to 58 kilojoule per mole. Okay, when a weak acid or weak base is heat of neutralization is always less than 57.1 kilojoule or 13.7 kilocalorie per mole. Why it is so? Because either it is weak acid or it is a weak base. When it is getting neutralized by acid and base neutralization reaction, that at that time this complete dissociation of weak acid or weak base will not take place. So some energy is required to ionize it, and that energy is called ionization energy of weak acid or weak base. Okay, so that required energy, from where do we get it? The reaction energy which is released during neutralization, that some amount of energy is utilized by the these weak acids or base for their ionization. That is why it will become less. Okay, because amount of energy is released, that is 57 kilojoule per mole, I am saying so. But that amount, few amount of this will be used in the ionization of it, that is it will become lesser. So 50 instead of 57.1 kilojoule or 13.7 kilocalorie, it will be less value than this, which we are getting from the strong acid and strong base. Okay, strong acid, strong base, always 57 and 13 or minus 13.